scheduling activities to make sure that they don't start too late, don't start too early, finish on time, and all the rest of it. Now, that means that we're going to need some extra information. So you've seen a kind of a table already, a precedence table. You've got activities A to H and their immediate predecessors, but in the middle we've got how long each activity takes. Draw this network off this table, but in addition we're going to put the length, the duration of each activity onto the network. Do you recognize what's particular about this network? We have talked about it before. What sort of issue is there going to be when it comes to drawing this? Dummy activities, I heard somewhere. Is that what you're saying? There's a dummy activity here, C, because C is so there's a dummy activity. So you're happy with that network representing that table? You see we've got A is 8 units, C is 1 unit, E is 3 units, G is 2 units, and so on. That's all gone in there. Dummy activities, you have to draw them in, but they always have 0 cost or 0 time taken, because that's what they are. They're dummy. They're just there to complete the drawing. They don't actually exist as an activity. So they'll have a 0 in there. And that's important when you come to analyze these and find out 2 things, 2 basic things. First thing that we're going to be finding out is what we call float times. An activity's got a float time if there is more time available for completing it than it's going to take. You might have 10 days allotted for putting down the concrete down Northbourne Avenue, but it's only going to take 7 days. That means you've got a float time of 3 days, which means that you don't have to start as soon as you need to. You can start up to 3 days late. Following my numbers there? You've got 10 units of time to complete something. It's only going to take 7. You've got 3 units. You can have that at the beginning or the middle or the end. That's 3 units. You've got 3 units spare. It's called float time. The other thing that you're going to get off this is something called the critical path, which is the path through the network which has got no float time. Everything is critical. Everything has to start and finish on time. That's why it's called the critical path. We'll very quickly find out what that is by doing the procedure. So those 2 things are going to come out of what we're going to do next. Now, what we're going to do, in addition to drawing the network and putting the numbers on them, is draw some boxes. When you do these activities, procedure, if you have to draw one straight from scratch, you're going to have to put in, next to every vertex, a box big enough to write 2 numbers in it. A box big enough to write 2 numbers next to every vertex of the network. I'm not going to do them all here. I'll show you what it looks like in the end. 1 down there, 2 numbers. And you're going to be filling in these numbers, and from the numbers that you fill in, you will find float times and critical paths. So those are the boxes. That's what it will look like. Basically, this is what's in the textbook. They very inconveniently in the textbook talk about yellow boxes and blue boxes, which doesn't really help because you're not going to be drawing them yellow and blue. The first box, I'm just going to refer to the first box and the second box in each vertex, okay? So how do we find the critical path and identify float times? You fill in these yellow first boxes first, and you're going to fill them in going forwards. When we've done that, we'll fill in blue boxes going backwards. So the yellow ones are going to go in first, in that direction, and the blue ones are going to go in second, going in that direction. What am I talking about? You always start at 0, just the yellow boxes only, or just the first boxes only. And for the next one, you add on the duration of the activity. So 0 plus 8 is 8. Got it, Abby? 6. Here, 8 plus 1 is 9. Tina? 8. Now, be careful. 9 plus 0 is 9, or is it 6 plus 2 is 8? The answer should be 9. Thank you for pointing that out. I've forgotten there's 2 ways into that. Quite right, thanks for that. But that still makes this one 9 plus 3 is 12, or 9 plus 1 is 10. The answer is still 12. All right, so even dummies have an issue here. Now the blue numbers going back, I'll just go to another slide so that I can show you a completed tidy one. So that's those numbers filled in as of the book. Now going backwards. Going backwards, you start with whatever you finished with, which is 15. You subtract the activity, and you're still not going to get the same numbers. 15 minus 1 is 14, all right? In here goes 12. Going backwards, there's two ways of going back into this one. Same as there were before, as you just said. So is it 12 minus 3 is 9, or is it 11 minus 0 is 11? We want the smaller number. So going backwards, it's the smaller number. And then after that, there's no issue. 9 minus 1 is 8. 11 minus 2 is 9. And that's going to be 8 minus 8, or 0. It's going to be 9 minus... It's going to be the smaller number again. 8 minus 8, or is it 9 minus 6? It's 8 minus 8. Now, from the pairs of numbers, float time is in here. That's got a float of 2. This has got a float of 3. There's the difference between those two numbers. So that's how you get floats off the table. 9, or it could start at 11 and still finish on time. You see this one? If you start here, you've got 1 unit of time that's going to take it up. Do we start at day 9 or whatever it is, finish on day 10, or do we start on day 11 and finish on day 12, or somewhere in between? As long as we finish on day 12, it doesn't matter. So there's a float. That's one thing. And then the critical path, the other thing, is the path where there is no floats anywhere. So there's no floats there. 12, 12, 9, 9, 8, 8, 0, 0. That is called the critical path. This A and C and E and G and H all have to be completed on time for the whole activity to finish on time. There's no spare capacity to delay. This one, you can take 3 units spare here, and you've still got a couple of units spare there. As long as you get to here by day 12, you're fine. So that's how you get the numbers, all right? So forward, you add and choose biggest if there's a conflict. And backwards, you subtract. This is the essential thing you've got to have in your notes. You subtract, and you choose the smallest if there's a conflict. Now, in the textbook, they talk about things like EST for earliest start time and LFT for latest finish time. You don't need those things right at the beginning of the exercise. I'll clean them up tomorrow if you need help with them. But basically, what I'm going to do next is jump to the exercise and just work through with you. There's one mistake in the exercise, so that'll confuse you if you don't listen. There's your finished one with the red line marked in as a critical path and float times, as I said. Just to explain in the exercise, we have to find the number that is represented by a letter of the alphabet, lowercase, algebra variable p. What's p and how do you find the answer? Now you're going forward, scanning from 8 to p, so what do we do to get p? It's 8 plus 4, so it's 8 plus 4 equals 12. Some people have done these already, just check you've done them correctly. Do them now with me or do them afterwards or just watch as you wish. But please, some contributions would help. What about the letter W? 10. Because, yep, 4 plus 6 equals 10, thank you. Now we've got M and N. Sorry, you have to do the yellow one. Yellow one by forward scanning. Something plus 4 equals 12. M plus 4 equals 12, so M equals 8. And what about N? Is that forward? Is that got by forward or backward scanning? N. Backward, because it's blue boxes, so it's 12 minus 4 is 8. 12 minus 4 equals 8 for N. Let's do A first. So what would A be? Backward scanning from there.